Hi and welcome to the 2019 Paper 1. This is the Junior Cert Higher Level Question 10. So as always, if you want the set of notes I'm working off, just send me an email at shanetroy@gmail.com. My email address will be in the description below. So question 10 here is fairly okay. There's no parts to it, it's just this is it. And you're asked to draw each of the following two functions in the domain. So basically using the x values, x is greater than or equal to minus 2 and less than or equal to 2 plus 2 for x is an element of R. So all that really means here is for every value of x between minus 2 and plus 2. Now you could pick minus 2, minus 1.99, 1.98 and have 1,000 points and then draw that, but you're not a computer. So be sensible and just use the biggest ones, the easiest ones. So that's every number between minus 2. Okay, so I'm going to just use the whole numbers. Okay, and that's giving me 5 values, which should be enough to draw any graph. To draw a graph, you need coordinates, and those coordinates are mapping how x changes relative to y. Now, we could do this different ways, okay? But this is Junior Cert, not like Leaving Cert. But it's worth pointing out there that, which may not be necessarily the most important thing right now, but I could factorize this and find out where or what are the factors of this quadratic, because this shape is a quadratic equation, or sometimes called a second order polynomial. And if I found the highest common factor, okay, I could say how to express this as the product or the multiplication of two algebraic terms, and you could pull out, I think that 2x can be pulled out. Now if I multiply that by 5 minus 2x, I'll get the same answer. So that leads me to the two factors are either 2x is equal to 0, which means x is equal to 0, or they could be 5 minus 2x is equal to 0. Now if you bring the 2x across, you get 5 is equal to 2x, so x is equal to 5 over 2. Now they represent the 2 points where the thing crosses, so somewhere over here, where the quadratic crosses the x-axis. There is no last term on its own, so I know that it doesn't cross the y-axis, or rather crosses the y-axis at 0. Okay. Now in Leaving Cert, you'll go and do the max and mins as another section. You don't have to do it in Junior Cert, and that can find the turning point of the shape. But what they're really trying to do here, and that was a bit of a tangent, okay, is they're trying to see, can you use this equation with the values of x we just talked about to find the 5 corresponding values of y. So if I take the first one, minus 2, and I go, okay, when x is minus 2, what is y? So all I'm being asked to do there is input minus 2 instead of x everywhere I see it in the equation. Now I'm doing a sample calculation here. So I can put that through the calculator, okay, and now I'll do it by hand because I don't have my calculator handy, but plus by minus is minus, 10 by 2 is 20. Then in this second term as such, you do the powers first. So it's minus 4 times minus 2 squared is minus 2 times minus 2, so it's plus 4. Now that leads to another, just going to try solve it down. Minus 20, now minus by plus leaves that as being a minus. 4 fours is 16. So just do that subtraction. I owe you €20. I borrow 16 more off you. I now owe you 36. So the two values there are when x is minus 2, y is minus 36. And that's why it goes down so far. Okay, so now minus 2 should be somewhere over there. Now I've got this done. I'm going to go straight to the answer because it's tidier. I've shown a sample calculation there. Now once I have the calculator programmed, I don't have to show the calculation like 5 times. The answers I got here was minus 14, 0, okay, 6, and 4. And they are the corresponding values of x I chose, 0, 1, and 2. I have 5 points, so I plot them, okay, whatever. Minus 1, minus 14 was somewhere down here. We knew that was 0, 0. Okay, so we did predict it was going to cross at 0, and it was going to go, that's where y was equal to 0. We also said there was no number at the end, so it was going to cross there. 1, x or y is 6, somewhere there. And our last one, 2, is the x value, y is 4. Now, if we kept going, we knew from the factorization, it was going to come down over here somewhere. And that looks, I'm guesstimating, that's 2.5. Now the second equation, okay, is an exponential. Okay, so that x is a power. So it's y equals 3 to the power of something. Again, I'm going to use -2 as far as +2, and the whole numbers seem to work. So throw in your calculator 3 to the power of -2. Now it should be worth pointing out that 3 to the power of -2 is the same thing as 1 over 3 squared, and that's the reciprocal rule of powers, which basically works, if I use an x term, 1 over x to the power of 2 is the same thing as, well, 1 times x to the power of -2. If you try that with numbers, 1 over 2 squared, is that the same as 2 to the power of -2? Calculator will show that this is 0.25 and this is equal to 0.25. They're equal, so that is a true statement. So that's the crux of that, okay, example. And so 1 over 9 is our first point. So when x is -2, your y value is 1 over 9. Now, exponential graph gets big, basically gets larger each time. Because you can see there, the difference between here and here is whatever. The next jump is a lot bigger than that. Not twice, more than twice. And the next jump here is way, okay? So exponential graphs get as they get bigger, go up to infinity, is one way of putting it. So that's what we expect to happen, okay? Now, when we go through our different calculations, so we've shown our sample, -2, -1, 0, 1, 2. So that gives us 5 points, okay? So I plot them there, and that's what my graph looks like, okay? And that's it. So handy number, really. It's just basic, in a sense, quarter geometry, but just for kind of crossed over algebra. So that's question 10, okay? So see you on question 11.